Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, in this video we'll discuss about escape velocity of an object from the surface of a planet. That planet might be the Earth. Students, let us start with the escape velocity. Escape velocity of a planet. Now, if I have a planet here, and the object is here, I want this object to escape from gravitational influence so that it never return back. Then I have to make its total energy zero. To make total energy zero, how much speed I provide, that velocity I provide to this object is known as escape velocity. So escape velocity is if I provide a velocity v which is equal to escape velocity, then it will not return back. So it should be the minimum velocity. So the minimum velocity provided to the object so that it never returns to the planet again. Never returns back to the planet again is called as escape velocity. Escape velocity. So now I provide V, so mass is m, so its kinetic energy will become half mve square. So I provide that velocity in the form of kinetic energy. So this is the energy I'm providing so that it will never come back. And that energy must be equal to the binding energy, because binding energy is that energy to make it free, and this energy is provided in the form of kinetic energy. So equating that, I have half mv square is one of an object resting on the surface of the Earth. The binding energy is this one, g/mm over r, that we discussed last video. The kinetic energy is 0, the potential energy is minus g/mm over r, make it plus positive, that is the binding energy. So from here, I'll just cancel out which is common on both sides. Escape velocity Ve from here is 2 times under g/m over r. This is the final expression for the escape velocity for an object which is resting on the surface of the Earth. Now this escape velocity and the orbital velocity that we discussed earlier, we can relate them. Escape velocity is under root g/m over r. Orbital velocity or critical velocity is under root g/m over r. Critical velocity of the planet or satellite. Planet, if it is revolving around sun, satellite, any satellite revolving around planet. So comparing these 1 and 2 equations, we will have a relations between VE and VEC. VE over VC is under root 2 because that will cancel out. So escape velocity is root 2 times orbital velocity. Escape velocity is root 2 times the orbital velocity. Okay, so this is about the escape velocity and the relationship between the escape velocity and orbital velocity. Thank you.